There's our EOC study guide. This is day number 1, picking up at number 11 on part 2. Number 11 says a geologist measured the width of 4 microscopic crystals. Which width is the largest? The first thing you need to do when you get a problem like this is you need to check and make sure all your units are the same. They are. In this case, they're all centimeters. The next thing you want to do is you want to look at the difference in their exponents. -3 versus -2. Remember, as you're looking at scientific notation, each number in the exponent means you're moving it one more time or to one more decimal place. So like 8.6 times 10 to the -3, 8.6, it actually moves over 3 times. 1, 2, 3, and that number is 0.0086. Same thing with 3.21 times 10 to the -3. 3.21, it still moves over 3 times because it's to the -3, 2, 3, and you fill them in. So that's 0.00321. Notice 0.0086 is higher than 0.00321. So it's definitely not this one. As you look at the other ones, when you compare them, you have 5.74. It says times 10 to the -2 compared to the -3. So that means you're only moving it once, twice. So 0.0574, notice that is much higher than 0.00 something. So it's definitely not going to be this. Both of these are to the -2nd power. So just pick the number that is larger. 5.74 is larger than 5.18. C is the correct answer. Number 12 says, what number must be in the shaded region in order for the probability of landing on that number to be 3 out of 8? So 3 out of 8. So what that's saying is out of 8 total, you want the number 3 to come up or have 3 chances. As you look at 7, notice 7, 7, and 7. There's 3 of them already. If the blue number was 7, then that would give you 4 out of 8. So it's not going to be 7 for sure. 4 out of 8. If the number was 1, notice there's only 1. So if the number under there was 1, it would be 2 out of 8. That simplifies to 1/4. That's still not 3 out of 8, so it's not 1. Same thing with 3. If you look at the number 3, if it was 3 and then 3 underneath that, it would be 2 out of 8. That'd be the same one. So the only one it can be, since you have the number 6, 6, 6, and there's one more 6, which will make it 3 out of a possible 8. So C is the correct answer for 12. Number 13 says, what's the domain of the function? This is one of those things we didn't really concentrate too much on what the word domain is because it's really easy to show in review. If you're looking at all of these points, 1834, 2264, and so on and so forth, if you would write them all in a column, they would look like this: X comma Y, or 1834. The second would be 2264. The third one would be 94. This isn't something you have to do. I just want to show you something real quick. 11, 18, and then finally 91, 45. Your domain values are your X values. Remember, it's D, and your range values are your Y values. If you can't remember which one's which, it's alphabetical. D comes before R, X comes before Y. These are your domain values. Some people thought, well, it's got to be 94 minus 18, or 94 through 18, or 18 through 94. No, that's the range, but that's range when you're talking about central tendency. When you're talking about data as central tendency, when you're talking about individual functions in this case, it's the numbers 18, 22, 94, 11, and 91. Had it asked you for the range of this function, you would have given all the Y values, so it would have been D in that case, but it's all of your X values. And again, alphabetical order if you get stuck. So number 14 says, what's the range of the function? What are the Y values now? Remember, D was domain. You got to look at it this way, X, Y. This is your domain. These are your ranges. So now you're looking for your Y values. Which ones represent the Y values? Notice this one is 1, then 2, then 3, then 4. So all of your Y values from here to here will be between numbers 1 and 4. So when it's showing the numbers between 1 and 4, as you're looking at it right here, it says x is less than or equal to 4. And it says if you look at it the other way, x is greater than or equal to 1. Remember, you read it from the variable. But we're not talking about the x variable, so it's not that one. This one says from -2 to 4 and -2 to 4, so it's not that. The last one says y's value, y is less than or equal to -4, and y is greater than or equal to 1. D for number 14 is your ranges, D. Or D are your ranges. 15 says, does the graph represent a function? And then it's yeses and nos and horizontal and vertical line test. First off, there is no such thing as a horizontal line test. Okay. So immediately get rid of those. We have talked about vertical line tests. We never talked about a horizontal line test. So as you are checking the vertical line test, all it's doing is you're drawing a vertical line through it. You just need to draw one, but if you can draw a whole bunch of them, it's okay. You can draw a lot of them next to each other, whatever. If the graph itself crosses through one of your vertical lines more than once, like right here and right here, then it fails the vertical line test. It can only cross through it one time. So in this case, it crosses through it more than one time. So no, it is not a function because it fails the vertical line test. The number 16 says Heather ate 2 cookies with 90 calories each, 1 glass of skim milk with 110 calories, and a sandwich for 212 calories. She thinks she consumed 502 calories. Estimating to the hundreds place, there you go, to the hundreds place, which of the following expressions would verify her calculation? So what you need to do is you need to take all of the numbers and round them to the nearest 100. So from 90 to its nearest 100 is 100. So you don't want this one, you don't want this one, and then we'll check on the last one. We don't want 90. Then it says glass of skim milk. The nearest 100 for a glass of skim milk is 100 again. So this estimate is 100. This one's 100. And then it says a sandwich. Its nearest estimate is 200. So you have 2 cookies, so 2 times 100, or 100 plus 100. A glass of skim milk plus another 100 plus a sandwich, 2 more 100. B is the correct answer. Estimating to the nearest 100 place.